Okay, so this video shows you how to calculate viscosity from liquid compositions. So I'm just very quickly, you should have got this from Thermobar, read the docs. So you're going to navigate here, going to go to the latest build, and if you scroll down, you will find this under the other functions, calculate viscosity. There's a video showing how to do this on YouTube. Very simply, you click here, and then click download, click here, and then click download. You then want to take these two files and put them in whatever folder you want to work in, and navigate to that folder in your Jupyter lab. So here I put these two files in my YouTube narration folder. We can look at the spreadsheet you downloaded. We're going to read from this tab. So this is liquid compositions from a MELT model, and you notice they do not have underscore liquid after them. And then here's some of the viscosity calculations that were performed using a different tool. So what we're going to do is, if you haven't installed Thermobar, do so here, and then we're going to import this all. We then load the Excel spreadsheet, we load the sheet name, and because we do not have that underscore liquid, we add suffix equals this, just so that Thermobar gets it in the right format. We take this dictionary, which contains a data frame of liquids and an input data frame, and we extract the liquids one, and we call this liquids 2. We are going to want to just look at liquids 2 and check that it makes sense, check that none of the columns with zeros you're expecting to have data in. Okay, and then we're ready to perform viscosity calculations. So in this input spreadsheet, there already was a column for the temperature of the melt in Kelvin from Thornber that was calculated in another program. So what you can say is that you want to calculate viscosity, you specify the liquid composition, so here it's our data frame liquids 2, and then you basically want to take the data frame which has all of your input columns, which is called licks input 2 here, and specify the name of the column with temperature in Kelvin. And then we can plot the results. We've got to run this first. You can see here we are plotting viscosity against magnesium content and viscosity against silica content. Now, Thermobar obviously has all of the liquid thermometers. So say you don't want to read in temperature from your spreadsheet, you can use the help function, and you can see these are all of the available thermometers. So here I'm going to calculate temperature using equation 13 of Paterka 2008. Again, I specify my liquid compositions. This calc T ec 13 returns the temperature in Kelvin, which I then feed into the viscosity calculation here. And we can then plot these. So we're going to compare the temperatures calculated with Thornber we got from our spreadsheet with those calculated using Paterka 13. And you can see they differ more and more towards lower magnesium contents. By default, Thermobar doesn't really have an input column for fluorine because it's not used for most models, but this viscosity model from Giordano does have fluorine in. Often as well, people think of fluorine in ppm, say they've got it from their electron microprobe, whereas this model wants you to input the fluorine as F2O. So the first thing we've done is written just a little function so you can convert fluorine to F2O. So here we've said, say we've got 1000 ppm fluorine, to say we've got a constant fluorine amount. So we're going to just run that. So now we can just double check if you want that this converts back and forth correctly, and if you did it the other way around, you'd end up with 1000 ppm. So now we're going to calculate the viscosity with fluorine, using our liquid composition, using our input temperature, and using our calculated fluorine content. And we can plot here, and you can see they are slightly different. And you could instead load in a column of fluorine data or whatever you want. You do not have to use a single value here.